Well, good Sunday, everyone. There we go. Yeah, and like Cherry introduced me already, I'm the director of Quantside Lab, so that means that I spend a lot of my time working in open source, thinking about how to sustain open source, hiring people to work on open source, and asking corporations for money for open source. Right, so I just spend all my time at work thinking about open source. For those of you that find it easier to go through the slides for like PDF or whatever, you can find the slides there. So I'm just going to make a quick pause. You can find it at bit.ly/OSS-success-24. There's also a handy QR code. And I'm going to be very honest. I tried to write this talk many times. I changed it many times depending on where my mind was, what I was working at. And the reason why I'm giving this talk is because I've been working and contributing, volunteering, maintaining, building open source projects and communities for over 15 years. And throughout those many years, I've seen many challenges, many opportunities, many changes in the industry, in open source, in our communities. And like I said, I spend a lot of my time, probably more than what I would like to admit, thinking about open source, what success means, and why we even do open source. So let's start with the first of a few hairy topics I'm going to talk about, success. And I want you to think about what are some of your favorite tools or libraries or apps or programming languages. Some of my favorites are here, and these are tools and libraries that I reach to time and time again for different reasons. You see a broad mix of things in there, but those are all tools that I have to use on a very regular basis, some of those every day. So when I ask you that question, like, what is your favorite tool? What is your favorite programming language? What is your favorite app, your favorite library? There must be something that makes them special for you. There are different things, there are different motivations that bring that one tool back to you time and time again. Sometimes you have to use it and you fell in love with it. Sometimes they're just convenient. Sometimes they allow you to do things that otherwise you weren't able to do. And that specialness or awesomeness or joy to use is part of what makes an open source or a tool, an open source project or a tool successful. But if we really, really want to go a bit deeper and think, what does actually success look like for an open source project? As many things in our industry and in our domain, the answer is it depends. It depends on who you're asking this question. It depends on the context you're asking this question. And it also depends on the baseline you're asking this question for. It's going to be very different, your criteria of success, if you are considering using a tool in your production environment within your company. Sometimes it's going to be different if you're trying to get your VP or CEO or decisions makers to invest or fund an open source project. But more importantly, because open source projects and communities are complex socio-technical systems, there is not one single way for us to say this is the definite factor or the definite triad or couple of factors that determine success in an open source project. There are many, many things that you can count in there, like security, inclusion and diversity, adoption, documentation, governance, accessibility, usability, and so on. And you will notice that I am not adding any vanity metrics like GitHub stars, or likes, or number of hashtag mentions of social media. But ultimately, the reason why open source exists and why software exists, why we take so much pride in our craft of building software and tools and applications is because we're building this for people to use, for people to get better lives, for people to do their jobs easier, for people to enjoy doing their jobs. And you're building these tools with people. You're not building these tools just for machines. The times where software was intended for machines only is very long gone, and now it is intended for humans. So when we talk about success within an open source context, we have to remember that that success means different things to different people. Because again, we're building things for people, with people. And for you to start even defining the success of your project, of your tool, of your library, you have to go back and define, like, who are you supporting? Who are you targeting? Who do you have in mind when you build that thing? Is it an end user community? Is it a developer community? Or are you targeting many different groups? And I just said developer community, but you can say, well, data scientists, researchers, research software engineers, designers, hobbyists, activists, journalists, like whatever your group is, whatever that person is that you have in mind, that is who has the biggest weight in saying what success means, what success looks like. And knowing who you're targeting here, like knowing who you're who's going to be interacting with and benefiting from your project is key to set your priorities and your strategy right. And this is a very complicated thing in the Python community, the Python language, because Python is great at many things. And you can do anything and everything with Python. If you want to do video stuff, like generation stuff, you can do that. If you want to do investigative journalism, you can do that. If you're a hobbyist, you can do that. Like, you can do whatever you want, but that means that we have a very, very broad of success definitions, and that makes it extremely challenging to have a single North Star for a success. But regardless of who you're thinking about in terms of usage or benefit or support, there are a lot of traits that good tools or awesome tools or joy to work with tools share. The first thing is they enable users to do stuff. Like, they empower them to get things done. And they do not strive to do the job for the user. And like, I'm talking here, yeah, ChatGPT, all of those buzzwords that's not the goal of a tool. Like, replacing a person or doing the job for them is not the goal of a good tool. Also, for those of you that are probably familiar with the Unix philosophy, like, good tools find their niche and stick to it. Like, in Unix, there's like do one thing and do it well. Like, the tools that I have consistently had a lot of frustration with and eventually end up dropping because they've just become so complex are those ones that try and do everything for you. Like, if you remember, some of my favorite libraries or tools that I mentioned in the beginning are very tiny, very specific things. All right, I know I use ls all the time to see what is in my directory or where I am working, but I have found ISA that is a better alternative. And it's just so small. Like, the context in which they operate is so small, but it makes a huge difference in my quality of life when I have to use that every day, multiple times. These reasons. Also, good tools do not reinvent the wheel, and they preserve context. And this is extremely important when we're operating in such a complex system where we have too many options, where a lot of our work relies on piping things and gluing things and making things interoperate with others. They also help users to experience their first aha moment early on. Like, you have a limited window in which you have that fresh mindset, this new user, this newcomer experience. And the sooner the user gets to experience this, aha, or that first success is critical for them to stay around or decide to try another tool. Also, they work well with other tools, meaning that, again, if we were to think in terms of the Unix philosophy, they're composable and extensible, and very important, they're intuitive. And by intuitive, I mean they do what people expect, not what you, as the builder, as the person putting these things together, think what they should expect. Right? Like, you minimize surprises for them. You try and give them feedback early on whether what they're doing is what is expected or not. And this is one of the biggest misses that I keep seeing in many of our tools. Like, we put ourselves in the place of builders and users and try to think what they want and give it to them in a way that makes sense to us. But really, the more intuitive and the closer your tool is to your user needs, is like the higher chance of success and adoption your tool is going to have. Now, I mentioned in the previous slide, one of the traits is tools do one thing or find their niche and stick to it. But then here I have other things that are composable and extensible. And I know that at the beginning that can sound a bit counterintuitive, or like they even contradict. It's like those principles contradict themselves a bit. So when I think about tools and software, I think about Lego blocks. Like, you have a big, big, big bucket of Lego blocks. And the reason why we have small units of Lego blocks is because you can put them together in many ways, in convenient ways, stack them, unstack them, rearrange them. And it avoids any single piece of your building stack to be monolithic and have too much ownership. But instead, you're enabling the user to self-serve. You're enabling the user to think and take ownership of what they're building. It also helps reduce the blast radius in case something goes wrong, right? In case your tool, for whatever reason, fails. Because also, let's be honest, your users are always going to find ways to use your tool in ways you didn't think about. And so the more constrained your niche and your blast radius is, it also allows for that experimentation or unexpected usages, and sometimes they're good unexpected usages, and sometimes they're terrible unexpected usages. But especially so, we have to remember that we put software together in like this Lego brick format where one piece stacks to another or builds upon each other, and the input from one piece goes to another. Sometimes they work together, blah, blah, blah. But the most important thing is, like, if you think about this Lego or niche approach, is you also allowed your programs to be extensible and to be worked on later on by future generations, by future maintainers, by future developers. On the part of being extensible and composable, it's also a good way to allow your users to leverage the existing ecosystem. And it avoids a lot of maintenance burden on you. Like, you want, if you have Python users, you want them to use the goodness of the Python language, leverage a lot of the things that make the Python language good at, instead of having to reinvent and know everything yourself in your tool. Now, you have to be very judicious about what extensibility means, because that can be your friend or your enemy. But again, if we go back to the Unix conventions, like, these Unix environments were built for this exact purpose. And that's exactly how they work still today. Right? We have a standardized input, standard errors. We have a lot of signals. We have a lot of exit codes, other mechanisms that have prevailed and are consistent throughout, and that allows us to put all of these tools together nicely. So if you work, for example, on a lot of automation and scripting, you're probably used to dealing with a lot of plain line-based text. So if you're just operating in this Unix, for example, space, it's very easy to piece commands. Take your JSON, then you do some manipulations, use, I don't know, find things, like use awk and grep and whatever. But having this composability affords us more structure and compatibility than anything else. So again, remember, your users are always going to define success. And your job as someone building tools for your users is finding ways to empower them and be successful. Think about how you're building those Lego blocks and allowing them to stack them. You do not want to own all of those pieces. You don't have to. We have a very, very, very vast ecosystem and very rich programming languages that help you do that. It's more like a Lego bucket of things and less like Tetris, where you have predefined tools and your user, or you, if you own all of them, have to find the just very right way to make everything work without exploding, dying, blowing up, losing a life. But this all sounds very, very nice in theory. Right? Sounds, yeah, it's very easy. Blocks one after another. When I find that my tools niche or my scope is broadening, I stop and build another tool. But the reality is that chaos ensues. All complex systems lean towards chaos. Entropy is our friend and our nightmare. And in our current landscape, we rely on libraries developing on top of other libraries. And as soon as different development and production paradigms emerge, then chaos ensues. I don't know if some of you remember the whole area of cloud migration and how we suddenly were faced with needing network configuration, then cloud vendor topologies, that eventually prescribed or described how our applications were going to look like inside our companies and when we present those to our clients, our customers, or users. And then this very beautiful Unix philosophy of composable, usable, well-designed tools to work together became a situation of putting together jigsaw puzzles with hammer, scissors, tape, whatever you could find, just to hold them and make them work. And the nice thing, maybe, of life and tech is that innovation and shakedowns come in cycles. This was true for cloud migration and continues to be true. It's still non-trivial to get production-ready applications out in the world or deployed machine learning applications out in the world. So it's not different. We have another big paradigm and another big shift that we see, and that has brought so many people into our programming language in the Python community, is the emergence and strengthening of machine learning, data science, and now AI and all of those things. But the reality is that there is a whole lot of trial and error in getting these things out into the world. It's this very tricky maneuvering of levers until you find that very right balance. And if something goes off, everything just falls apart. I'm playing with sometimes houses, like cards, and things are very brittle. This is something that sometimes we don't talk about enough in the field of machine learning, how brittle things are sometimes, like how changing one little thing in whatever side of your pipeline can lead to like really disastrous outcomes. So even folks at the top of the field recognize that machine learning is a bit more like alchemy and a bit less like that very joyful development experience where things are composable and well behaved. And this comes a lot to design, right? But we're still talking about software development and maintenance. But if we think about design, if you've never worked with a designer or you're not a designer yourself, design sometimes feels like something alien. But in reality, design is concerned with how people interact with technology. Like how that interface between your users, your community, you, and technology work. So this is another framing trap that is very, very easy to fall into as maintainers or developers or engineers. We sometimes think we are just making technical implementation decisions. When we're building a tool, when we're thinking about how we build our API, how do we name something? We think it's just an implementation detail. And like, it's easy to fall for that. In reality, what we're doing is making design decisions. And we're making a whole lot of design decisions as we build things for people. And more importantly, we are deciding on and building pathways for success for our users. Sometimes we are not building pathways for success. We're building walls that our users have to climb. And this is because we assume that user-first or user-centric design or development is the same as assuming, again, what user wants and how they want it. Because, again, it's very easy to fall in that trap of, I am one of them, I am building this thing because I know what they expect. And sometimes that works, and sometimes that works out beautifully, and sometimes it doesn't. And I'm going to give you a brief example that is another hairy topic, but it's a topic that I think about a lot. I work on packaging, environment management. I don't know if you've seen, for example, the new libmamba solver in Conda, if you're Conda users. That was in my mind and in my works for over 2 years. A lot of my very good friends and favorite people in the community work in packaging and environment, and I love them, and they're very brilliant and talented people. So this is not a dig at this. I could have chosen any other example of things. I could have chosen like visualization tools, or I could have chosen dashboarding tools. It's just, this has been on my mind a lot recently. I've had so many conversations, I've contributed to things, I've had to recently change computers and build everything again from scratch. So, as someone who works on this topic and has to deal with this topic as an end user as well, I have to recognize that things are chaotic. Yes, they're chaotic. They're getting better. Probably less fast or not as fast as we'd like as users, but they're getting better, and we have a lot of people that care about it. So if you remember at the very, very beginning when Python started, and then when libraries started becoming a thing and you could install things in composable units that other people were building, there was one, and life was good. That was pip. Pip install blah, pip uninstall blah. Easy. As our life got a bit more diverse, we started getting people coming from other parts, realizing that Python was a good thing for other things, scientific computing, numerical analysis. Then their needs changed, their success criteria changed, and there were two, Conda and Pip, and life was still good. Where are we now? And there are many, many more. And life is just confusing. And this is, again, it comes back to the nature of Python is such a flexible and lovely to use and versatile programming language that people come from many different places for very different purposes. And as that has happened, then so their needs and success criteria have changed. And again, if we go back to that Unix principle of building small, composable, doing thing tools, this makes sense. If we just look at it from that very one perspective, it makes sense that as we have more and more diverse use cases, new tools emerge so that to satisfy those use cases. That makes absolute sense. The problem is they're not building blocks anymore. They're not those nice and neat Lego pieces. There are this diagram, there are these Venn diagrams where we have package management, Python version management, package building, publishing, environment management, a big part, big parts where they intersect. They work like each other, but not really. They work with each other. You're expected to know when to pull one in and when not. And that is just confusing. So, what does this mean again for our users? Let's think about Ravi. Ravi is an investigative journalist focused on data-driven factual narratives detailing the corruption of local governments in the global south. This is Ravi. They need to analyze data that they get more than likely from the government websites or from other many sources. They're going to be CSVs, JSON, maybe they do a lot of scrapping, whatever. They need to identify patterns, check facts, and then create narratives and visualizations that are compelling and explained in an understandable way for the general public. That is the context, and that is what Ravi needs to do. Notice that that's their success criteria. Having this analysis and these visualizations out in the general public in such a way that they can understand it. That is the baseline of success that Ravi has. For one reason or another, he has Python installed in his computer. I don't know, maybe he inherited the computer. Maybe he just realized that his operating system comes with Python. And he's heard that Python is good at these things. And he's right. He would be very right. So how do we get Ravi from that state of, I have Python, I know it's a good tool, and I need to create this general public facing visualizations and narratives? How do we get him there? Well, we need to get him those Lego blocks. How do we get him the tools that he needs, right? And for these purposes, I'm not going to go into he should be doing building environments because that is the right way to do it. He doesn't care about that. He doesn't know what an environment is. He only knows what Python is. He only knows that I need something to load a CSV file. Then I need something where I can see statistics, where I can see some trends and create a visualization. So let's stay within the package management circle-ish. And packaging is such an overloaded word because it means a lot of things. So, and if we look at today, there are still some tools that are not in that Venn diagram. I think that Venn diagram is 2 years ago or 2 years old, 3 years old at most. I can't remember. So I'm introducing Pixie and UV to the mix because they are popular tools that people are using. Now, let's look through a usability and discoverability lens at pip, content, Pixie, and UV. Because the most important characteristic of good design is, of a good design or a good, well-designed tool is discoverability and understanding. I, as a user, can find how I am used or expected to interact with this tool, or how to use this tool to satisfy my needs. A good design in general communicates this to the user. Now, we have a big challenge because I'm talking about things like pip, content, Pixie, UV that we use through a command line. So that gets even harder than when we're talking about UI interfaces and apps, because when you have a UI, you have a lot more things that help indicate state and interactions and show information. So how do we make our tools usable and discoverable? If we go back to the basics of design. And there are these things called affordances in design. It's a very well-known term, and this explicitly explains the relationship between the properties of an object and the capabilities of the agent. In design, they use the word agent a lot to signify user or personas. And these affordances determine how the object could be used. And so a user, ideally, on a good design tool, system, whatever, should be able to know what to do with the tool with minimal guidance. Example, we can see through glass. Glass affords seeing through. It's transparent. But we can also pour water into glass. But glass affords containing water. Like that is affordance, like what it is enabling the user to do with the object. And some of these affordances are easily perceivable. You can use any of your senses and almost immediately make that connection of what one thinks does, or like how you're expected to interact with a thing. Some others are not as evident. So we make use of something called signifiers. And these are perceivable signals of the affordances. And their main purpose is to direct and guide the user and increase the discoverability of the affordance. Now, how many of us have used a door? Many, right? A door affords passage, and there are traditional doors. Two ways to do that. Push and pull, right? If you see a handle or handlebar on a door, you assume pull. How many times have you faced a door where it has a handle and you pull and it doesn't budge in? You're expected to push, right? So that is a poorly implemented signal. If you add a sign that says push, then you have that other perceivable signal that says this door affords passage through pushing. That is what we do. That is what affordance and signal are. And we do that all the time with software. So, again, we're trying to get Ravi the tools. More than likely, they're going to go to Stack Overflow or other places, like how do I install things, because then they learn that there is a thing called pandas. They're gonna see this Venn diagram and say, I'm gonna try Conda, Pip, UV, and Pixie. Probably some of the ways that many of you, I certainly do, is like to get these affordances and signifiers is I install the tool and quick do a -- help. So pip for example, doesn't give you an affordance or a signal of what it is intended to do on the command line. But if you go to their documentation or to the GitHub repo, the first thing you see is that affordance. You can use pip to install packages. That's the affordance. Pip affords installing packages. Then with --help, you get the signifiers on how it enables you to do that. Right? Gives you usage examples, it gives you commands. And the first thing you see there is installs. It checks, right? The affordance affords installing packages. The first command is installs. Let's see how Conda does. Affordance. Conda is a tool for managing and deploying applications, environment, and packages. Okay. Okay, makes sense. Then the scope is way broader, right? When you do the --help, you go through all of that. I of course streamed a lot of this stuff that was not relevant for this example, but you see install there. UV. Package installer and resolver checks. Signifier drop-in replacement for common pip and pip tools workflows. Or commands, or capabilities, or affordances. I don't know. But when I do UV --help, I don't see anything that tells me install straight away, right? And its affordance is afford, install, and resolve. And at first sight, I don't see that. It makes it hard. I see then pip. And if I have built a mental model of pip install, I can probably assume and say, this does pip install somewhere. Fixing. A versatile developer workflow designed to streamline the management of your project dependencies, tasks, and environments. And once again, the scope broadens. And there's another term I want to introduce that is consistency. Right? And this means that we're preserving that context in maps. Like learning tools, learning workflows, building workflows takes time. The first thing that you notice, or Ravi's going to notice, is there is not a lot of, there's some consistency, but not throughout every tool. UV pip is the one that stands out in this example. Okay, let's be a bit flexible here, and when you have a tool that becomes sufficiently complex, then you can reduce its complexity by adding different layers. In this case, we call them namespaces. So UV pip is a namespace. If you look deeper, you actually see UV pip install is a thing. When it says install packages into the current environment, right? For someone like Ravi, environment is a new thing. So probably look at how consistency looks inside or within the same tool. We have UV pip that is resolve and install packages. But then inside UV pip, we have compile, sync, and install. And I don't see resolve there. I see compile and sync. I don't see install. But then you see a pattern of noun, noun, verb. Right? UV pip install, noun, noun, verb. If I look at other commands inside UV, I just see noun, noun. Like UV VM, create a virtual environment. I don't have the verb there. So these are examples of, these are just 4 tools that I chose, but you can do this exercise with all of the tools and applications out there, and you're going to see that our world is filled with inconsistencies, and that confuses people. That makes our job hard. Because building that muscle memory on the command line and learning flags and learning patterns takes a lot of time. And when you stumble across inconsistencies, you doubt yourself, you become less efficient, and working becomes less joyful. And there are many ways in which we can make things more discoverable. we can provide comprehensive examples, documentation, giving the user ways to self-serve. We build in perceivable signals where there are no perceivable signals so that people know that there are affordances that they're looking for. And generally, by making things discoverable, we reduce the time for users. First aha moment, that key moment that gets a user, like where a person becomes a user of your tool. So what does this have to do with building and maintaining and sustaining open source packages? It has to do everything. Because, as I said, our industry is cyclical. Chaos ensues. Things get more and more complex. That's not going to go anywhere. We had the cloud paradigm shift, we have machine learning shift, and now we're seeing another shift. Like everyone wants to do AI stuff, LLM stuff, build the new ChatGPT. And that introduces, again, different mental models. This introduces a different level of complexity. And this is a real question that people have asked. Now, they're not concerned about how I get this tool to, or how do I install something that I can read my CSV files with, and then how I install a tool to create visualizations. Now the question is like, how does one package and share language models? Because that's where their head is, that's where their success criteria is, that's where their needs are. Right? It might not match with how it pans out in implementation, but that's their baseline for success. That's what people are looking at doing. And these are the pathways for success that we are going to have to enable, like moving forward, and things are going to change. So as someone building the tools, as a maintainer, developer, builder, hobbyist, however you want to define yourself, a lot of our work is about designing pathways for success. And this means our users, our contributors, our project itself. And that means that we're going to have to make trade-offs. We're going to have to say no, especially if we want to remain in that composable structure and we want to find our niche. And I didn't say it then when I presented some of my favorite tools, but there are three tools there, actually. Hypothesis, Spacey, and Scikit-learn. I love them because they're boring in a good way. I can't remember the last time that I had to really worry because things absolutely broke and I didn't have a clue what was happening in there. They're consistent, they are robust, they are reliable, they name things in a way that I know where things are coming from and how they relate to each other. And that is a good boring because it makes my life easier. It allows me to focus on the things that matter. But to build that experience, you need to meet people where they are. You need to meet people where they're defining those baselines for success. Identify what it means as success and build what they need. And as a maintainer, you're going to have to make this decision time and time again. Maintain something, enhance or extend, do not support, sunset. Those are the basic type of decisions we make all the time. Not only in how we write our code, but like our governance, how we make decisions, how we work with each other. And to do that, you need to listen to and adapt to feedback. So the next time, or as you go back and build tools and software, think about this. Try to build tools and software that are intuitive, flexible, yet robust, simple and consistent, and empowering. When thinking about your project and how you're going to make decisions and work with each other, adopt governance, again, that is intuitive, empowering, simple and consistent, flexible yet robust. Because you can build on that, you can extend on that, you can iterate on that. It makes people, if you have good governance and good contribution documentation, people can self-serve, get their first aha moment, and they feel empowered. Also know that these are a lot of nice principles, and there might be times where you have to break these rules and these principles. But when you do so, do it with intention and clarity of purpose, not just because it can be done. Like, you have to be very intentional. And this matters again because this is a clear pathway that you're setting, like from your user to success. And that translates into then probably that user becoming your advocate and your sponsor, or your contributor and maintainer. And when you're making these decisions, we're deciding on pathways for success for our users, for our contributors, for our stakeholders, and for our project. Thank you very much. I was just in time.